In the last chapter, we covered standard ACLs. They filter based on one thing: source IP address. Useful? Sure. Precise? Not really. They're a blunt instrument. Enter extended ACLs. These are the precision tool. You can filter on protocol, source, and destination IPs, even TCP and UDP port numbers. Granular control over exactly which traffic gets through and which doesn't. The fundamentals stay the same. ACEs are processed top to bottom. There's an implicit deny at the end, and you apply them inbound or outbound on interfaces. So let's jump right in. How do we configure extended ACLs? Extended ACLs match on a variety of parameters: the protocol, TCP, UDP, ICMP, OSPF, source and destination IP addresses, and for TCP or UDP, port numbers configuration is similar to standard ACLs but with more keywords and arguments. You can use numbered extended ACLs, numbers 100 through 199, or 2000 to 2699, configured in global config mode, with the access list command. Or, extended ACLs, a core syntax, permit or deny, then protocol, source, and destination. A packet must match all of these. Partial matches don't count AFI. For protocol, specify ICMP, TCP, UDP, OSPF, or IP to match all IPv4 regardless of payload. For source and destination, use any for all IPs. Host IP at AFIRF. For single address, Nawisnago have Tender. With these three parameters, you can write precise rules. Block all TCP from host A to LAN B, or permit only ICMP from one subnet to another. And placement matters. Extended ACLs should go as close to the source as possible because they block only intended traffic. No need for unwanted packets to cross your network before being dropped. Add port matching to the mix, and you get even finer control. When your protocol is TCP or UDP, you can specify source ports, destination ports, both, or neither. If you leave a port unspecified, all values match for that position. The syntax adds an operator argument between IP and port, EQ, GT, LT, NEQ, or range. EQ means equal to, like EQ80 for HTTP. GT is greater than, LT is less than. NEQ is not equal to. And range lets you specify a span like 80 through 100. Some well-known ports have keywords: FTP, Telnet, domain for DNS. Boots and Boot PC for DHCP client and server, TFTP. www. These replace the port number in show command output. And a critical detail: when you filter client to server traffic, the protocol's port number is always the destination port, not the source. So, to block HTTP access, you match on destination. Let's practice with a real scenario. 3 server LANs, engineering and accounting departments. 3 requirements from the security team. Requirement 1. Only ICMP between server LAN A and B. We need 2 ACLs, 1 on each direction. Permitting ICMP but denying everything else between those subnets while allowing traffic to other destinations. Apply them inbound on the server-facing interfaces of Router 2. Requirement 2. Engineering can't use HTTP to reach server LAN A or B. 1 ACL on R1 inbound. Denying TCP destination port, www. From engineering to both server subnets and permitting everything else. Requirement 3. Deny all TFTP from accounting. Simple 2-entry numbered ACL. Deny UDP destination TFTP. Permit IP any CLORE. Applied inbound on R1. 4 ACLs total, and all 3 requirements are met. This is the kind of granular control extended ACLs give you over standard ACLs. What happens when you need to change an ACL after it's been applied? The order of ACEs matters. So sometimes you need to delete one or insert a new entry between existing ones. Here's the gotcha. If you try to delete an ACE from a numbered ACL using global config mode with no, the entire ACL disappears. You can't selectively remove ACEs that way. Only delete the whole thing. Named ACL config mode fixes this problem, and it works for both named and numbered extended ACLs. Enter the ACL with IP access last extended. Then use no followed by the sequence number, like no 30, to delete ACE 30. You can also insert new ACEs between existing ones by specifying a sequence number at the start of the command. By default, Cisco increments by 10, so ACEs are numbered 10, 20, 30, leaving room to insert. What if you run out of space between entries? Use IP access list resequence, followed by the name or number, then a starting sequence and an increment. For example, IP access list 2, resequence 1010, and iOS will automatically redistribute the sequence numbers, giving you room to work again. Extended ACLs filter on protocol, source, and destination IPs, plus TCP and UDP ports. You configure them as numbered ACLs in global config mode, or named ACLs with IP access list extended Dwader-tort matching uses operators, EQ, GT, LT, NEQ, and range, plus keyword shortcuts for common ports. Packets must match all conditions in an ACE to be considered a hit to extended ACLs